All right, let's just jump right in. Welcome to this explainer where we're going to mechanically break down the fascinating, yet honestly incredibly fragile water cycle of the tropical rainforest. If you've ever wondered how this ecosystem functions as a perfectly calibrated self-sustaining machine and exactly what happens when you throw a massive wrench into those gears, well, you're in exactly the right place. To really grasp the stakes of this environmental breakdown, we have to start by asking a pretty heavy question. What kind of force is powerful enough to dismantle such an ancient, perfectly balanced system? I mean, we're talking about a biome that covers just 7% of the Earth's land area, but somehow houses a massive 50% of all plant and animal species on the planet. So what on earth is disrupting it? The tragedy of deforestation is just staggering when you look at the before and after of human intervention. On one side, you have this impenetrable canopy of lush green. And then on the other, a scarred, burning landscape that's been completely stripped of its natural engineering. It's a jaw-dropping transformation, and not in a good way. Here's our roadmap for today. We're going from a pristine forest straight through to total systemic collapse, covering the perfect water cycle, the drivers of destruction, breaking the balance, the domino effect, and finally, the deadly feedback loop. Let's kick things off with Section 1, the perfect water cycle, basically a giant hydrological machine. To understand this undisturbed environment, you really have to stop looking at it as just a bunch of trees and start seeing it as an enormous biological water pump. The hot equatorial climate drives these frequent, super intense rainstorms, right? Now, normally, dumping that much heavy rain on bare dirt would just wash everything away. But here, those extreme weather events are masterfully managed by dense, incredibly rich layers of vegetation that have literally spent millions of years evolving to handle exactly this kind of deluge. The very first mechanical step in this machine is interception. When a massive rainstorm hits, that dense canopy acts like a giant umbrella. Raindrops are caught on the huge surface area of all those leaves. And because it's so hot, a huge amount of this intercepted water just evaporates directly back into the atmosphere. It literally never even touches the forest floor. Crazy, right? Next up is evapotranspiration, which is the actual biological pump of the forest. Whatever water does manage to infiltrate that rich humus soil is immediately taken back up by incredibly deep tree roots. The trees move this water up through their xylem vessels and release it right back into the air as vapor through these tiny little pores in their leaves called stomata. It's this constant, endless recycling that maintains steady river flows and local humidity. And it all builds into this beautiful, continuous loop. The canopy intercepts, the soil infiltrates, the roots evapotranspire, and that moisture rises to form new clouds that just rain right back down. It's a completely brilliant, self-sustaining recycling program. But we have to talk about Section 2, drivers of destruction, or throwing a massive wrench into those gears. When human disruption throws that wrench in, whether that's through partial removal, which we call degradation, or complete removal, deforestation, the sheer scale of it is terrifying. Globally, we are destroying 31.5 million acres of forest every single year. To put that into perspective, that is 1 acre gone every single second. Tick, tick, tick. An acre is gone. Subsistence farming leads the global chart at 59%, followed by commercial agriculture at 16.5% and logging at 10%. Now, while cattle ranching looks like a smaller chunk on the global scale, you have to look at the regional impacts. In the Amazon basin, for example, cattle ranching is the absolute dominant force. It causes a staggering 80% of regional deforestation just to supply industrial slaughterhouses, eating up over 8.4 million hectares of land. We're also seeing the rapid rise of highly profitable cash crops like palm oil, especially in places like Indonesia. These plantations rely on a ruthless slash-and-burn clearing technique. They just cut and burn the trees to provide this short-term ash nourishment for the soil. But once the palm oil is harvested, the land is effectively left totally useless. On top of that, mineral extraction for things like gold, copper, and diamonds literally tears the earth apart. Not only does this require clearing out massive tracts of forest and building huge roads, which, just invites even more illegal logging, but it also poisons local rivers with mercury. This toxic runoff completely devastates aquatic life and indigenous communities like the Yanomami tribe. Moving to Section 3, breaking the balance. This is where we see complete system failure. So what actually happens mechanically to that incredibly efficient water pump when it suddenly loses its parts? Well, it fails completely. In a disturbed system, fewer leaves mean less interception. And those protective litter and humus layers on the forest floor, they just vanish. So when the heavy equatorial rains fall, the water violently washes over the land as surface flow instead of soaking in. And that leads directly to severe, devastating flash flooding. Which brings us to Section 4, the domino effect, and its cascading consequences. You see, the damage doesn't just stop at the surface with a bit of extra water in the rivers. No, it triggers this massive domino effect that ruins the very foundation of the forest, the soil itself. Removing the canopy lets intense rain hit the exposed ground with its full, brutal force. And without dead leaves falling, the decomposers have absolutely nothing to add back to the soil. That heavy rain then essentially just washes or leaches any surviving nutrients straight down through the soil profile. What's left behind is basically a barren, infertile wasteland. And finally, Section 5, the deadly feedback loop, the catastrophic breakdown. Once the soil goes infertile and that delicate water cycle is disrupted, the biome enters its most alarming stage yet, a catastrophic positive feedback loop where the damage actually starts amplifying itself. With fewer trees, there's less atmospheric moisture and less evaporative cooling. So the forest literally starts to heat up, causing any surviving plants to suffer from fatal water stress, what we call dieback. These dry, dying plants then absolutely skyrocket the risk of wildfires. And when they burn, the soot particles act as aerosols in the atmosphere, which further inhibits rainfall. It's a vicious cycle. Drought creates fire, which incredibly just creates more drought. And look, this matters profoundly to all of us. Why? Because 80% of all land-based species live in these forests. Through these destructive practices and the resulting collapse of the ecosystem, human activity is driving extinction at a rate anywhere from 1,000 to 10,000 times beyond the natural rate. Protecting this biome isn't just about saving some trees. It is absolutely crucial for the survival of the planet's remaining biodiversity. Ultimately, breaking this delicate cycle doesn't just destroy the local ecosystem in Brazil or Indonesia, it sends a catastrophic shockwave through the entire global climate system. Deforestation impacts global wind patterns, atmospheric moisture levels, and major environmental systems way beyond the tropics. Which leaves us with a pretty urgent question to consider about the very real global consequences of this localized destruction. If tropical regions continue to grow warmer, drier, and more infertile, how will the collapse of this natural machine permanently alter our global carbon balance? As the rainforest water pump grinds to a halt and millions of acres of carbon-storing trees go up in smoke, what happens to the rest of the planet? It's a massive system failure that we simply cannot afford to ignore. Thanks for exploring this complex biome with me today. Keep asking questions and keep learning.